Okay, so I have the computer space board hooked up to power and video. Last one I did, this is my second computer space repair. Now the last one I did came with this plug right here. It was included, so I was able to plug it in and wire everything up to that. Well, this one didn't have that, so I had to come up with making my own plug. Now I don't have the AC. There's 12 volts AC on these two pins. I don't have that hooked up because I don't care about that right now. So I have the power hooked up and I have the video hooked up. This is actually for the audio, which I don't care about right now. But I had to make this wiring, and I've got it to where it'll connect to the original splayed connectors. You know, like this. So that's my video connection. I just have it right here wired in. So, yeah. And I will confess, I've already had this thing powered in, and I set the voltage to about 4.85 to 4.9 volts. So I'm happy with that. And I'll show you what it's doing. So let's fire it up. Okay. And it's on this monitor here. And yeah, this is what it does. You can kind of see the game playing. And you can see the score and stuff over here. You can see the two flying saucers. Yeah, and you can kind of see how this works. You can see the whole screen moving along with, so the saucers are not actually moving, the whole screen is moving. See that? So it's like that portion of the screen is overlaid over the stars. So you can kind of see the stars in the background. Yeah. Computer space. So we have that's a motion board issue, I would say, because it is the motion board, and you know, the motion with the saucers. So we'll start right there with that motion board. And you know, another thing I want to do with this is I do remember last time I did one of these repairs, I remember this thing was pulling over 3 amps. But after I replaced all of the green capacitors, it went down to 1.8 amps. So I do want to test that again. I want to see what this thing is drawing the way it is. And then I want to, well, if it's drawing more than 3 amps, it needs to have these green capacitors replaced. Because the power supply that came with this game is rated at 3 amps. And if you're drawing over 3 amps, it will not power this board. So I want to check that out. All these caps have to be replaced. And we'll have fun testing those and seeing how bad they are, if at all. So, you know, so we'll see. Yeah, but I mean, this is a good start. The video is good, the sync is good, and everything. It's just we have a motion board issue. Then we got to go through the sounds and all that good stuff. Yeah. Yeah. So we'll do that. We shall do that and make sure that our rotation looks right on our ship. You know, that's all right here with our spaceship. We can see that the saucer right here, these diodes, we can see that looks, I think that looks okay. I'm not exactly sure yet. We'll have to clear up that background. So this is This is the memory board. The star board, I think, is the bottom board. And I believe the middle board is the motion board. So I think what I'm going to do is remove this board. And then start poking around on this board right here. Hey, after removing that top board, I turned it on. I rechecked my voltage to make sure I'm not way over 5. And I'm actually still at 4.9, so that's fine. And here we have a cleared up star field. So it seems the problem, I don't know which board's which, I'll be honest with you. Maybe this is the star board. I don't know. I'm going to have to, I did get the schematics printed off for this. So I will find out. I'm sure that's the memory board. I'm sure of that. So we have problem on that board. The memory board is that, and this is the motion board though, I think. And I think this is the star board that generates all the stars and the, wait a second, I can kind of see I can see the spaceship. He's right there. See him? I can see it. So it is actually moving. The motion looks like it's working. You can see where it would be. I don't know if you can see that on here. See that? Now he's moving. Yeah, it's kind of hard to see, but you can see the outline. So the motion's working. The motion and the stars are working. That's these two boards. So I think that is where our problem is just on that board, which is nice. So we can pop that one back on and start probing that guy. You know what I might do is replace, I'd like to just replace all these capacitors. First and foremost. Let's do that. Let's do some maintenance before we do anything. Go through and recap all of these electrolytics. And then once we do that, let's hook it up to my bench power supply and let's find out how many amps this thing's drawing. You know what I could do is I could just run this through my meter as well. It'd probably be easier. Yeah, that would probably be easier, I guess. Anyway, yeah, let me figure that out. Let me see, how do I want to do this? Do I just want to use my switching power supply and run it through my meter to get the amps used? Or do I just want to hook it up to that and get the amps used? I don't know yet. But the sticking point for me is the actual hooking it up. I definitely do not want to hack my plugs and put these on. Unless I have some that are already broke. Which I very well might. There's one that's already broke. There's one that's got a broken, well, maybe I'll use those two. You know. What's this? Oh, that's... There you go. That one's broke. I do have two that are already broke. A red and a black. So I can put splayed connectors and just run this board right off of my power supply. I'm going to do that right now. Let's check the amp. Let's check the current draw. Okay, I went to start stripping these guys to use those to plug into my power supply to hook to this. And this red wire right here is so thin, that thing is not a power wire. And neither is this one. These are really thin. These are signal wires. So I can't use those to power this. So what I did was I did sacrifice a couple of ends. And these are, as you can see, these are clearly for power. You know, that's a big thick wire. So what I'm going to do is I'm going to attach, solder on some good wire to this, lengthen them out from that, and then crimp these two guys on there so that I can plug that into there and then plug it into here and run it, so that I don't have, you run power through something like these little flimsy things, you're going to lose amperage in the wire and they're going to heat up and stuff, and you don't want that. They have to be rated. They have to be rated to be able to handle the amperage. Otherwise, you're getting a false reading. So, yeah, so let me do that. Get these things prepped. And, yeah, I'll be back. Okay, yeah, and I made this little power harness, which I'm glad that I have it now, as I'll always have this. And I double heat shrinked it. Yeah, soldered together, double heat shrink, and got the splayed connectors on here. That'll hook right into this power plug on the board set. Let's find out how much this draws. All right, I got this hooked up. The white wire is 5 volts that goes to the red here, and it's coming over here, 5 volts to the red. Okay, now I do want to just plug in the monitor and turn it on so that we can watch it come up. Okay, here we go. Power on. And we will slowly bring it up to 5 volts. Okay, we're at 3 volts. Still nothing. And we're up to 4 volts. And at 4 volts it comes up. And it's working. Now we'll go up to our 5 volts. Okay. 2.83 amps, but what we need to do is we need to measure this on here. So I don't have my tripod out here, so let me go ahead and measure the voltage. I'm going to set this to 5 volts. So this is going to be more than 5 volts up here. But you want 5 volts on the board. So let me go ahead and do that. Okay, and you can see we're at 5.05 and we're 5.3 here. So we got a little bit, not much of a drop. Because we got good wire. That's the thing, is we got good power wire. So we're not dropping much through here. I remember last time I did this test, I dropped like a whole volt. And even more than that. I was at like 6 or something like that, or 5.9 or something like that. So I dropped more in the line. Now I'm not dropping as much in the line. And we're at 5.05 on board, measuring it at that cap. And we're drawing 3 amps. 3.6, 3.7 amps. That's not good. So we are going to have to go through and replace all of those decoupling caps. If every one of those is up in the, you know, billion ohms or whatever of leakage, every one of those is in parallel. So every one of those that is leaking is going to divide the total resistance down. So those things, I guarantee you, we'll test them, and I guarantee you they're leaky. Otherwise, see, a regular power supply that was issued with this game back in 1974. This game This board is from 1974. I saw it marked. This must have been a later production run, because the boards are stamped 1974. And this thing came with this little 3 amp rated power supply, and it would struggle, if not even work at this, because this thing is drawing over 3 amps. So we're going to have to rectify that problem so that this can stay original. You can still get those power supplies. The very power supply that came with this, you can still get those, but it will not work with this. It's really on the cusp. You know, because that thing is rated at 3 amps. It'll only really support up to 3 amps. So this thing should be outputting, this thing should be drawing less than 2 amps, really, if it's healthy. This one's just not healthy. So we're going to go ahead and we're going to make it healthy. Yeah, and just observation, this cage is in immaculate condition. It's really clean game here. Yeah, your extended plays, test pattern, all this good stuff. Set that over here. And yeah, you'll see, where's them stamps at? 1974. Yeah, February 1974. February 7th, 1974. Okay, let's do some maintenance on this stuff. I'm going to remove and replace every one of these capacitors. Okay, let's do that. And all of the electrolytics as well. And then we'll revisit that test and see what it draws then. All right, check it out. All of the decoupling has been replaced. All of the electrolytics have been replaced. And I got all the old caps here. And we're going to do some cap testing, have some fun with it. Let's get to it. Alright, before we do the cap testing, I wanted to hook this back up. And I've got it back at 5 volts on the board. And we're still right at 3 amps. So this thing is just... If we had all LS parts on here, it'd be different. But we don't. So yeah, it's drawing more power than it should because these are all high power parts. These are not LS parts. It's the 74 series. These are not 74 LS series. These are 7400 series. And they just draw more power. So this thing was power hungry from the get-go. I know on the first one that I did, the first repair that I did for computer space, I had to replace a lot of the chips, and of course I replaced them with LS parts, and that's probably what brought the amperage down. But after just doing the caps and everything, check this out. It's working. Looks good. Looks just like it should. Yeah. Now I know that these caps were bad up here. And we're going to go ahead and test those and kind of have some fun with that. And check them all out. But I know they were bad because they looked nasty. So see how many of them are open. But yeah, I feel a lot better. All that decoupling's replaced. If these had some LS parts on it, it'd really bring that power down, but it is what it is. You know, it's just this board right here has about 30 161s on them, but they're 93 16s, and those are power hungry. So yeah, it just is what it is. We're right at 3 amps. Yeah, it is what it is. Anyway, it's looking good. So I guess the next thing to do is just check the sounds, check the controls, and make sure the scoring and the counting works right. After, of course, we check some caps. Okay, we're going to go ahead, and I don't think any of these are going to be shorted. I think they're going to be open. Electrolytics generally don't short, they open. So, I'm going to start with all of those caps on the memory board that are like this. Let me, I can't see. That are like this, folded over on that top board. We'll do all of those first. I'm just fishing them all out of the pile. Okay, almost. Alright, yeah, I got them all. These are all 47, they're 50 microfarad. This one is a 250 microfarad. We'll start with that one. 250. And you can see it has drifted way high. Which, I wonder what the ESR is on that. Generally, if they drift high, the ESR is probably good. You know, it's probably just a cap that has drifted in value, but is actually not technically bad, but it's just out of tolerance. Yeah, 0.2 is the 0.2 ohms of ESR. That's actually not, this is not causing an issue, this cap. That cap's actually okay. I mean, it's out of tolerance, yeah, but you know what I mean. Okay, now this one is 50 microfarad. And it's up to 82. And it's the same thing. It's just out of tolerance. So it might make something, it might make the thing spin a little bit slow, or you know, maybe your ship spins a little slower than it should, or something like that. It would affect something very minutely. Okay. Here's another 50. And this one's actually at 62 microfarads, which is not terrible. Okay. I need to put these somewhere after I test them. I don't have anything. This one is 20. I think this one's 20 microfarad. And it reads 28. Which is probably fine. Here's another 50. That one's 50 on the dot. It looks terrible. It's got really high ESR. 13 ohms of ESR. That's really high. That's really bad. Okay, here's another 50. Generally, if these are close to the rated value, That probably means that the ESR is really high at this stage, because they all drift. See, this one's at 59. It's probably got high ESR as well. And these should be right around 1 ohm. This one doesn't have any ESR at all. That's kind of an issue. That means that this is kind of open, I would think, right? Well, it says it's 50, but there's no ESR. I don't know. If there should be some ESR. That's weird. I think this cap is actually not good, because there's supposed to be some ESR. It's supposed to have some ESR reading. There's another 50, and it reads same 58. ESR reads, see, this one reads 6.5 ohms. It's a little high. This one, once again, this one reads nothing, no ESR. Well, now it's reading 2.3 ohms. Maybe I just wasn't on it very good. Okay. This one is another 47 or 50. And it reads good. And once again, we should have about 1 ohm of ESR, and it's 1.3. That one's actually not terrible. There's another 50. And that one's at 54 with an ESR reading of 0.5. That's not bad. All right, now these are little 10 microfarad caps. And that one reads 2. So this one is not good. ESR is going to be off the chain. Or no, there is no ESR. This cap is open. This one's open. Yeah, that one reads 2 microfarads. It's a 10 microfarad cap. There's no ESR. That one's basically open. There's another 10. That one's open. Check the ESR just for good measure. Yeah, it's open. Okay. Here's another 10. That's open. Let's move the scale down. Yeah. Move the scale down. It's reading half of a microfarad. That's basically open. There's not going to be any ESR on this thing at all. Yeah. And here's another. These are all 10s here. Okay. Yeah, same thing. It's supposed to be 10. That one's open. All these 10s are open. No ESR. Same thing. It's reading 1.5 microfarad. It's supposed to be 10. And we get no ESR. This thing's open. And this one is actually good. This one reads 13. And it'll probably be 30 ohms. That's way high. Normal is like 1 to 2 ohms. And it's 30. So that's really bad. Really high ESR. Okay, here's another 10. So far, almost all the 10s are open. And this one reads 6.9, which probably means it's got really high ESR once again. Actually, there is no ESR reading at all. If these things don't have any kind of ESR, that means they're really open. So I don't know why it has a reading like this. It has a capacitance reading, but there's no ESR, and it should read some ESR. It should not read no ESR. So I don't know. That's weird. Okay, now we're doing this is a 250 microfarad. And it's reading 288. A little bit high, not bad. And we're looking at 0.2 ohms of ESR. That's not bad. Here is a 50 microfarad. And it's coming up 59, which is not bad. And we have an ESR reading of 0.5. That's good. There's another 50. And it's 56, 57. And we're looking at 0.5 on the ESR reading. That's good. Here we have another one of those 250s. And it's 330. It's a little drifty. Not bad though. I mean, it's out of tolerance, but what do you expect? Some of these are actually in tolerance and stuff. This one's 0.2 on the ESR. That's not bad. These are also 250. And right at 250. An ESR reading 0.6, pretty good. Same cap, same type of cap. A little low. A little bit low. ESR is 0.3, not bad. Here's another one of those caps. Once again, a little bit low. ESR probably be decent. 1 ohm, 1.1 ohm. Nah, it's not bad. 1.1. It's a little bit high, but here we have a 100. And that one is 105, not bad. And 0.4, not bad. So here's a little one. Here's a 5 microfarad. Let's check that 5 microfarad. It doesn't look leaky at all. Uh-oh. That baby's open. Yeah, it's supposed to be 5. We probably got no ESR. Yep, no ESR. So that one's open. Open cap. And this one is another 100. right at 100. See if we're under an ohm of ESR. Yeah, 0.4. The cap reads perfect. And one more, last electrolytic, and it is a 250. And it's drifty, a little bit drifty, not terrible. Okay, and 0.2 on the ESR meter. So those, the bigger caps are actually pretty good. It's all of the smaller value. The small value caps are all bad. Well, there was one that had a really high ESR. That one of the 10 microfarad caps had a really high ESR and about 15 microfarad reading. The other ones were all open. And this little 5 microfarad guy, that one's open. So all the small value caps are bad. And next I want to put these on my leakage tester and see if these things are leaky. Okay, I got my little tester out. Remember, this thing is for small capacitance capacitors. You can't do electrolytics on this. It'd take an hour for it to charge a 1 microfarad cap to see if it leaks. But these guys you can do. And the way it works is you would look for this light, the LED on here, you look for it to extinguish. If it doesn't extinguish completely, there's leakage across the cap. And we'll just wait and see if this light goes out. It should already be out. Yeah, this thing is extremely leaky, this capacitor. And these are 0.2 microfarad caps. Just for a little comparison, I'm going to grab a 0.22 microfarad cap right here. This is a new 0.22 axial cap. 0.22. Yeah, you can see this one just doesn't go out at all. That just means that there's electrons jumping across the plates. It's not insulating. So if I take this new cap and hook it up, okay, now we'll watch that lamp, the little LED. It usually takes about 15 seconds for a 0.2 to go out. 15 to 16 seconds. You can see it's dimming right now. And it's completely out. If I short with just my fingers, I just have to do this with the cap, you know, and it shorts it between my body, uses my body to short the sides. Now we count to about 16 and this will go out. A 0.1 is half. A 0.1 takes about half that. It takes about 8 to 10 seconds for a 0.1 to go out. See there? It goes out. That's how it should be. But you can see that these caps are very leaky. This one is garbage. Just grab another random one. And give it about 16 seconds. Yeah, it's been about 20 seconds. This thing is not going to extinguish. This is the same thing I found on the last repair that I did. Is these things are garbage. These caps are really bad. They're just leaky. You're not getting good decoupling with these caps. So yeah, well, we've fixed that. I'll test one more random cap. All right, oops. One more. Okay. 5, 6, 7, 8, 9, 10. 16, 17, 18, 19, 20. Yeah, no good. No bueno. No good. And once again, just for reference, here's that new one. New cap. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Okay, about 24, I guess. I guess about 24 it completely went out. I'm going to grab a 0.1, and it should be about 12 seconds then, right? Something like that. Okay, this is a 0.1, and this is the kind of cap, this is the very cap that I put in this board for decoupling. So we should have about 12 seconds or something like that for this to extinguish. Okay. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, about 10. About 10 seconds. So yeah, 0.1, about 10 seconds to extinguish. So that's it. You know, these are all proven. They're just all bad. All this decoupling cap. These decoupling caps are bad. And what will that cause? Well, it's gonna strain the power supply for one. It's going to maybe cause abnormalities in the 5-volt line. You know, where it's not as pure as it should be. So maybe that's going to cause your screen to shake or something like that. You know, it can cause a bunch of stuff. But anyway, that's that. So, nice little tool to have. Okay, so back at the computer space. And I got it all hooked up with the sound and everything, with the amp. And I could hear the sound, but it was not amplified, so I replaced the 741 amplifier right there. Here's the original. It's the same part, but they made it into an 8-pin instead of a 14-pin. This is an early version, I guess. Same chip. But anyway, I realized after I replaced this and I was still faintly hearing the sound, but it just wasn't amplified. Well, I realized I didn't have the 12 volts AC hooked in for the audio. So I got this little transformer right here, and it outputs 12 volts AC. I got it hooked up. So we'll go ahead and fire this thing up. And now, unfortunately, for the thrust, I don't have a. I've obviously scammed the thrust switch. Now these are normally closed, and you have to open them up to activate the switch. So this thing's going to be thrusting constantly. And to stop it from thrusting, I have to just short the two lines together, these two, like that. So if we coin, and I adjusted the brightness down a bit. So if we coin it and then start, see we're thrusting. Now we're not thrusting. Thrusting. Here's rotate right. Okay. Here's rotate left. And here's fire. But it seems to be counting right. Yeah. The counting seems to be good. All the controls are good. I just wish that I could control that. I need another. I don't have another switch, unfortunately. So, but it does work. Everything's working. So yeah, it's very good. Still, I could actually tone down the brightness a little bit more. I can see the outline there. So I'll take and just darken it so slightly more. There we go. I can still see. I could darken it a little bit more even. But it looks good. Sounds good. Controls are good. Yeah. Just a bunch of dead caps. Dead caps, and had to go through and replace all the decoupling to make it easier on the power supply. Now this thing originally has that 3 amp rated supply, and remember this thing was pulling right at 3 amps, so it should be okay because the power supply that comes with it, I'm sure, does have a helping current resistor that helps bypass some of the current and then is regulated by the regulator, so it should be okay. This thing should have a buffer of a little over 3 amps on the power supply, but so I would say that you should be able to use the original power supply, and it might have it right above 5 volts. Should be fine. It should work okay, I would think. Yeah, but this thing's working as it should. Another computer space, good to go. Complete recap as far as electrolytics and decoupling. Got this thing back in order. Alright, that's going to do it for this. And I did get my flyback. I got my flyback, so I'll go ahead and make a quick little video of putting the flyback on here and getting this thing all squared away, and yeah, that'll be next. Alright, computer space. I'm going to let this thing sit here and run for a couple of hours. Come out and play it now and again. That's going to do it. See you guys. See you on the next Classic Arcade Repair.